This deep dive covers the IBM article by Cole Stryker entitled, How Do AI Agents Learn and Adapt Over Time?
Right. It's a really interesting piece.
Yeah, you shared it, and today we're going to sort of explore how these AI agents actually develop their skills, how they learn and get better.
Hmm.
Our goal really is to cut through some of the complexity, give you, the listener, a clear handle on the core ideas here, and importantly, why it all matters.
Sounds good.
Okay, let's dive in then. Fundamentally, what is AI agent learning? What are we talking about?
Well, in essence, AI agent learning is really the process, the way an AI agent gets better at what it does over time.
Okay.
This improvement comes from, interacting with its environment, processing the information it gets, and then using that to make its decision-making better.
So it's actively learning from doing.
Exactly. It's
That's
this
it.
ability to learn that lets these autonomous agents adapt to new situations and handle more and more complex jobs.
Right. So it's definitely more than just like following a basic script. But the article says not all AI agents actually learn. Can you clear that up?
Absolutely, yeah. Learning isn't universal for all agents. The article makes some good distinctions. First, you've got simple reflex agents.
Okay.
They just react. Input comes in, pre-programmed action goes out. No learning from what happens next.
Got it. Reactive almost.
Then there are model-based reflex agents. They sort of reason using an internal model of the world, but still no inherent learning mechanism.
Still no learning.
And proactive goal-based agents, they work towards goals. Utility-based agents try to maximize some benefit. But again, the core learning component, that ability to update behavior based on experience, it's not built in for those types.
So the learning agent is the one that's constantly evolving, yeah? What does that mean practically?
Precisely. It's always tweaking its approach based on feedback.
Mhm.
That's why they're so good in situations that are, dynamic or uncertain.
Right.
They can figure out multi-step problems, adapt as they go, without needing a human holding their hand the whole time. Think like a thermostat just turning on and off versus a smart home system learning your habits.
Ah, okay, good analogy. The article also laid out four uh, main parts of a learning agent. Can you walk us through those?
Sure. Typically, you'll find these four elements. First, the performance element. That's the part that actually makes decisions and acts based on what the agent currently knows.
Okay, the doer.
Then the learning element. This takes the feedback, the experiences, and uses it to actually improve the agent's knowledge.
The learner. Makes sense.
Third, the critic. Really important. It evaluates the agent's actions and gives that crucial feedback, maybe a reward, maybe a penalty.
The judge, kinda.
Yeah, exactly. And finally, the problem generator. This one's interesting. It suggests new actions, maybe things the agent hasn't tried, to encourage exploration and potentially find even better ways of doing things.
So it pushes the agent to experiment a bit.
Exactly. Helps avoid getting stuck in a rut. Okay, structure makes sense. Now, how does this learning actually happen? Machine learning is the key here, right?
That's right. Machine learning, ML, is really the foundation. It gives the agents the algorithms, the tools to find patterns in data, make predictions, and ultimately get better.
And deep learning, too.
Yeah, the article mentions deep learning, specifically using those complex neural networks to handle huge amounts of data and find really subtle patterns.
Okay. And within ML, there are different approaches. First up was supervised learning. What's the deal there?
So supervised learning is kind of like learning with a teacher or maybe with an answer key.
Right.
The AI gets trained on data where every input has a known correct output. Labeled data, they call it. By seeing loads of these input-output pairs, it builds a model to predict outputs for new inputs it hasn't seen before.
Ah, okay. So the example in the article, the AI chatbots trained on customer service chats, that fits here.
Perfectly. They learned good responses by studying tons of past questions and the answers that worked well.
Makes sense. And the article mentions other things too, like image recognition pictures tagged with cat or dog or speech to text, or even medical diagnosis from labeled scans.
Right, right. And then there's transfer learning. That sounds like taking a shortcut.
Sort of, yeah. It's about leveraging knowledge. You take a model trained on one task, often a very broad one, and you adapt it for second related task.
How does that help?
Well, the big advantage is efficiency. You don't need a massive labeled data set for every single specific task. The example was fine-tuning large language models.
Like the big ones, GPT and others.
Exactly. They're trained on, vast amounts of internet text. Then you can take that general knowledge and fine-tune it on a smaller set of, say, legal documents or medical papers to make it an expert in that specific area. It's much faster and needs less specific data. It's a strategy highlighted in resources from the AI Coach by Anil Nathu, focusing on that efficiency.
Very clever. Okay, moving on. Unsupervised learning. This sounds like the AI is kind of figuring things out on its own.
That's a good way to put it. With unsupervised learning, the AI gets data, but it's not labeled. There's no answer key.
So what does it do?
Its job is to find the hidden structure within the data, find patterns, groupings, relationships, all without explicit guidance.
Can you give some examples of where that's used?
Sure. The article mentioned clustering customer behavior. An AI might look at purchase histories and group customers who buy similar things, maybe for targeted marketing.
Okay.
Anomaly detection is another big one, especially in cybersecurity. Finding weird patterns that don't fit, which might signal an attack.
Right.
And recommendation systems, like on Netflix or Spotify. They often use unsupervised learning to figure out what movies or songs seem similar based on who watches or listens to what.
Gotcha. The article also mentions self-supervised learning. How does that fit in? It sounds like a mix.
It is, in a way. Self-supervised learning borrows techniques from unsupervised methods, but it applies them to tasks that usually need supervision. The trick is, it generates its own labels from the data itself.
How does it do that?
Well, for example, in language processing, it might take a sentence, hide a word, and then try to predict that missing word based on the context. The context is the supervision, in a sense. Or, in images, it might try to predict a hidden patch of the image from the parts it can see.
Huh. So it creates its own little learning puzzles from the data.
Exactly. It's a clever way to leverage unlabeled data for tasks that need some kind of predictive signal.
Interesting. Okay, last main type. Reinforcement learning. This is the trial and error one with rewards.
That's the core idea, yes. Reinforcement learning, or RL, is all about agents making decisions in complex, often uncertain environments.
How's it different from the others?
Well, unlike supervised, there are no labeled right answers provided up front. And unlike unsupervised, it's not just about finding patterns in data. It's about learning a sequence of actions to achieve a goal, usually maximizing some kind of reward. The article rightly points out it's not a classification method like self-supervised can be. It's about learning how to act.
So it learns by doing and seeing if the outcome was good or bad.
Precisely. The agent tries an action, interacts with the environment, and gets back feedback, a reward signal, positive or negative. The goal is to learn a policy, basically, a strategy for choosing actions that lead to the biggest total reward over the long run.
Right, maximizing the cumulative reward. The article mentions self-driving cars learning or chatbots getting better at conversations. How does RL apply there?
Okay, take the car. An action might be turning the wheels slightly. If it stays in lane, avoids hitting anything, maybe it gets a positive reward. If it swerves, gets too close to something, it gets a penalty, a negative reward.
And it just does this millions of times.
Billions, maybe.
Yeah.
Over and over, it learns which actions in which situations tend to lead to good outcomes, safely getting where it needs to go.
And the chatbot.
Similar idea. It tries different responses. If the user seems happy, continues the chat, problem solved. Positive reward. If the user gets frustrated, ends the chat abruptly. Negative reward. He learns conversational strategies that work. And, designing those reward systems effectively is crucial. That's something often discussed by the AI coach, by Anil Nathu, when talking about practical AI deployment.
That makes a lot of sense. Okay, shifting gears slightly. The article also stressed a couple of key aspects of these learning agents. First, continuous learning. Why is that so important?
Well, it's huge. Continuous learning means the agent doesn't just learn once and stop. It keeps learning, adapting as new data comes in without forgetting everything it learned before.
Unlike traditional ML models that train on a fixed data set.
Exactly. Those are often static once deployed. Continuous learning allows an agent to improve its performance in real time, out in the real world where things change. It also helps fight against what's called catastrophic forgetting, where learning new stuff wipes out old knowledge. For real-world apps, it's pretty much essential.
Yeah, you need that adaptability. And then there was multi-agent learning and collaboration, agents learning together.
Yes. This opens up really fascinating possibilities. You have multiple AI agents interacting. Sometimes they collaborate, work together towards a common goal. Sometimes they compete.
Okay, like what?
Well, for cooperative learning, the article mentioned swarm robotics. Lots of simple robots sharing info to achieve something complex together, maybe exploration or construction.
Right.
For competitive learning, think about financial trading AI. Different algorithms might compete, and in doing so, they learn better strategies to outperform each other.
That healthcare network example was really compelling too. Different AIs working together in a hospital.
Exactly. Imagine specialized agents for, say, monitoring patients, managing schedules, analyzing scans. maybe all coordinated by a more advanced agent, perhaps using generative AI. They could share insights, optimize workflows, potentially leading to much better patient care and efficiency. It's that kind of coordinated system, optimizing how different AIs work together, that the AI Coach by Anil Nathu often provides insights on.
Very cool. Okay, let's talk about the feedback itself. The article really hammered home that feedback mechanisms are key to guiding the learning.
Absolutely fundamental. Feedback is the information the agent gets that lets it know how well it's doing. Was that action good, bad, indifferent? It lets the agent assess and adjust.
Positive or negative reinforcement.
Right. But it's also important, as the article noted, that feedback, while crucial, isn't the entire learning process. It's the input to the learning element.
Gotcha. The article broke down feedback based on the learning type. What about real-time feedback?
Yeah, that's vital when things are changing fast. Self-driving cars, again, constant sensor data is real-time feedback about the world. Or robotic process automation bots might get immediate confirmation if a step in a process worked or failed. It allows for instant corrections.
Makes sense. What about feedback in unsupervised learning? If there are no labels, how does it get feedback?
It's more implicit. The feedback comes from how well the agent's internal model captures the structure of the data. For example, in clustering, the feedback might be a measure of how tightly grouped the clusters are, or how distinct they are from each other. Or in things like autoencoders, the agent tries to reconstruct the input, and the reconstruction error, how different the output is from the input, serves as the feedback signal to guide learning. That supply chain example, predicting demand by finding patterns without labels, that relies on this kind of implicit feedback. You can find more detailed examples of these applications on the AI Coach by Anil Nathu's site.
Okay, implicit feedback. And supervised learning, that seems more straightforward.
It is, yeah. The feedback is explicit and direct. The labeled data. The agent makes a prediction, you compare it to the known correct label, and the difference the error is calculated, often using something called a loss function.
And that error tells it how to adjust.
Exactly. That error signal is fed back to update the model's parameters, pushing it towards making better predictions next time. The e-commerce example, predicting what you might buy based on past purchases, uses your past behavior as the labeled feedback.
And the article mentioned human in the loop here, too, bringing people into the feedback process.
Right, HITL. It acknowledges that sometimes human judgment is really valuable. Humans might provide the initial labels, or they might review the AI's uncertain predictions and provide corrections. It helps refine the AI, especially in tricky or nuanced situations, making it more robust.
Okay. And reinforcement learning feedback, we kind of covered that.
Yep, back to the rewards and penalties. That simple scalar signal, positive or negative number after an action, is the core feedback mechanism guiding the agent.
And finally, self-supervised. Where does its feedback come from?
It comes from how well it performs the task it set for itself. Remember the predicting the missing word example. The feedback is simply whether its prediction matched the actual word that was hidden. It learns by trying to minimize that prediction error, which forces it to learn about language structure.
Wow, okay. That covers a lot of ground on how these agents learn. This has been super insightful. Before we wrap up, what are the big takeaways you think people should hold on to from this?
I'd say the main things are AI agent learning is fundamentally about adaptation and improvement through interaction and feedback. It's not one single thing. Machine learning provides a whole toolkit, with supervised, unsupervised, and reinforcement learning being key styles.
Right.
Also, the idea of continuous learning is vital for real-world effectiveness, and the potential for multi-agent systems, both collaborative and competitive, is huge. And finally, understanding how different feedback mechanisms work is key to understanding how these agents actually improve.
So for you listening, maybe take a moment to think about how these different kinds of AI learning might already be touching your life or your industry. Where could continuous learning make a real difference? And what about the ethics and potential of these multi-agent systems? Lots to chew on. And again, we definitely recommend checking out the AI Coach by Anil Nathu website for deeper dives and practical insights on these topics.
Yeah, it's really exciting is seeing how these different methods are constantly being combined and improved, leading to agents that are just getting more and more capable.
Thank you for joining us today. Visit the AI Coach website for more AI insights by Anil Nathu.
My pleasure.
And a final thought to leave you with. As AI agents get better and better at learning and adapting on their own, what new possibilities and maybe what new challenges do you see coming just over the horizon?